Section 7 in Chapter 1 is transformations in a coordinate plane. Okay, so some definitions that you need to know are transformations, pre-image and an image, translation, reflection, rotation. Okay, so those things. Alright, so first thing, what is a transformation? And a transformation is just a change in position, size, or shape of a figure. Okay, so right here I have the shape, it's a square, okay, figure ABCD, okay, there's a square ABCD, and what you're looking at right now is what we call the pre-image. It's before anything happens, it's pre-movement, so it's the pre-image, it's the original image, okay. The image is the new figure, it's the new change, okay, it's where the figure ends up, okay. So we use an arrow to show that a transformation has happened. So we would have figure ABCD is, and then an arrow, and then is the new figure ABCD. And we use little primes, okay, and I'll show you what those are in a minute to distinguish between the pre-image and the image. So first thing we have is reflection. Right? So when we are reflecting things, we're going to be doing it about the X and Y axis. So you reflect an image over a line, or the line of reflection. So in this case, I'm going to show you what happens when we reflect over the Y axis. So I'm going to flip that, and then I'm going to highlight this entire image, or pre-image, excuse me. I'm going to reflect it over. Okay, and when I label the new points here, display, label points, cancel. Okay, when I reflect it, this one would be P prime, because when I reflect it over, P or B would be right here. When I reflect this one, it would be A prime. I reflected it all the way across. Here would be D prime, and here would be C prime. Okay. Now, if you notice, the distance between this point, the original B, and the line of reflection is 1 unit here. The distance from B prime to the original image is also 1. Alright, that is also a characteristic when we reflect across a line. The distance from the original point to the line of reflection is the exact same as the distance from the image to the line of reflection. Okay, so A to the line of reflection is the same as the distance from A prime to line of reflection. And if you see here, this is what a prime looks like, a little dash right here above it. Okay, so now if you'll notice, I graphed the coordinates here. A is -4, 6. B is -1, 6. Okay, C -1, 3. D is -4, 3. If I do the coordinates for all of these points, I'm going to do B first. Coordinates, C, coordinates, D, coordinates. Now if we compare, notice the numbers are almost exactly the same, except the X values, this is a negative, this is now positive. It's because when you flip it over the Y-axis, the X values change. Okay, so they're the exact same, except you make the X value opposite of what it originally was for any one. So if I were to go from here to here, it would go from positive to negative. Okay, the same thing happens when I flip it over the X-axis. I want to rotate this figure. not rotate, excuse me, reflect this figure across the x-axis. Do you see this? It goes from here to here. Notice the distance. Alright, let's label the points. Okay. And the last one. Okay. Notice A prime. Now the distance from A to the line of reflection, okay, the x-axis here is 1, 2, 3, 4, 5, 6. The distance from A prime to the line of reflection, 1, 2, 3, 4, 5, 6. So the distances are the same. Okay. If I looked at the coordinates, I'll just do 1 here to show you. Let's see. Coordinates. D prime. If you notice, in this case, the x value stayed the same. The y values changed because I went from a positive to a negative. Okay, so when we have a line of reflection and it's the y-axis, the x values change their sign. So they go from positive to negative, or if it's negative, it goes to positive. If it's across the x-axis, the y values change and it goes from either positive to negative or negative to positive. The numbers don't change, just the signs. Okay? Alright, so that is a reflection. Okay? Let's look at a rotation. So I'm going to delete these points and delete these points. Okay? Alright, now rotation. Okay, a rotation is a turn about a point P, or P would be the center of rotation. Each point on the original pre-image and each point on the image are the exact same distance from P. So let's explain that or show it. So I'm going to pick a point of rotation. I'm going to highlight the figure. I'm going to rotate 90 degrees. Okay, so this figure here is now rotated. Display, show label, display, show label. If I do it all at once. There we go. So you see here, this was rotated 90 degrees. B was rotated 90 degrees. A was rotated 90 degrees. And D was rotated 90 degrees. Alright? So the distance from, and I rotated around this point, the center point here. So let's look at the distance from C to this point. Measure distance. 3.16 centimeters. Alright, now let's measure distance from C prime to E. Construct, or measure, oh, I'm going to highlight that. Distance, measure, 3.16. I can do this for every single one. A to E, measure distance from A prime to E, measure distance, same distance. So the distance from the point of rotation, P, and any point on this figure is this on the pre-image. So the distance from E to the pre-image is the same as the distance from E to any image point. Okay. Alright. So that is a rotation. Alright. Now, the last one, a translation. Let's delete that. Delete. Delete. Okay. A translation is basically just a slide in the same distance and direction. So if I wanted to, I'll take the figure here. Let's highlight all of it. Construct a translate. I'm going to move it There we go. I'm going to move it horizontally 5 units, and then vertically I'm going to move it down 3 units. Translate. So let's label all the points. Display, show labels. If you notice, I moved every point from the pre-image 5 units to the right. 1, 2, 3, 4, 5. And then I translated them down 3 units. 1, 2, 3. Okay? So, let's all get the coordinates for all these points. Now, if you look, -5 plus 5. I moved to the right, so that means my x value is adding value, so I added 5. -4 plus 5 is 1. I also moved it down, so the y value I'm going to subtract, so I went from 6 down 3 units to 3. Same thing with point B. I do it to every point on the pre-image. So -1 plus 5, 4. 6 minus 3, 3. -1 plus 5 is 4. 3 minus 3, 0. -4 plus 5 is 1. 3 minus 3, 0. Okay? I can do that any way I want. So with the translation, if I move it up, I'm adding to the y value. If I'm moving it down, I'm subtracting from the y value. If I'm moving it to the right, I'm adding to the x value. If I move it to the left, I'm subtracting from the x value.